In addition to the many transportation archetypes, there is an interesting transportation example built into RETScreen that demonstrates some additional functionality for fleets of vehicles. This example can be accessed from the home page through the Transportation item under the column of Facility Type Examples. The example facility has a fleet of on-road vehicles. The analysis examines the feasibility of applying several different approaches to reduce fuel consumption and GHG emissions. On the Energy worksheet, the Electricity and Fuels page provides costs for a wide range of transportation fuels, including gasoline, diesel, and E85 ethanol, a gasoline-ethanol blend containing 51 to 83% ethanol, depending on geography and season, and utilizable in certain so-called flexible fuel vehicles. Electricity, which can be used in plug-in vehicles, is also included. For the first two comparisons, the base case is a Honda Civic, and the proposed case is a Nissan Leaf in one and a Toyota Prius Prime in the second. The analysis also includes a third comparison where the remaining vehicles in the fleet are aggregated. The first two analyses, using the Honda Civic as the base case, employ method 1. In the first, a fully electric Nissan Leaf is compared to a Honda Civic running on gasoline. This type of comparison should look familiar. It is very similar to the archetype for the electric school bus fleet I looked at in a previous video, except that there is only one vehicle being considered here. In the second, the same approach is taken, but the proposed case vehicle is a plug-in hybrid, which consumes both gasoline and electricity. The percentage of the distance traveled on gasoline has been estimated at 70%. The combined consumption of gasoline and electricity is expressed in kilowatt hours of fuel energy consumed per year. For a distance traveled of 22,000 kilometers per year, only 7 megawatt hours of gasoline plus electricity is required annually for a Prius Prime, but nearly 15 megawatt hours of gasoline is required by the Civic. The third analysis, for an example fleet, uses method 2, which I have not shown in previous videos. This method allows for multiple vehicles of different types to be lumped together into a fleet. In fact, in this case, we're able to look at multiple approaches to reducing fuel consumption. Several strategies are employed for each group of vehicles. In some, a new vehicle replaces the existing one, either to upgrade to a more fuel-efficient vehicle or to switch to a vehicle that uses different fuel. And in all cases, the distance traveled annually is reduced, reflecting an organizational policy mandating carpooling for work-related travel when possible. Let's look at these in turn. For the 5 cars, we're exploring the feasibility of using more fuel-efficient vehicles to replace the existing cars. In both the base case and the proposed case, gasoline is consumed, but the proposed hybrid vehicle has significantly better fuel efficiency, 4.4 liters per 100 kilometers for the Prius, versus 8.7 liters per 100 kilometers for the Fusion. Note that the efficiency cells are blue, indicating that RETScreen can provide database values for these cells. The product database is opened by clicking on the shopping bag. For each manufacturer, model year, and vehicle model, the database provides information about the vehicle class, engine, transmission, and fuel, including the fuel efficiency. The fuel efficiency can be copied into the blue cell using the Paste Data button. The From Database icon in the blue cell signifies that the value for the fuel efficiency is the unadulterated value from the database. There are other differences between the base case and the proposed case, however. Through a policy requiring carpooling for work-related travel wherever possible, each car travels 1,500 fewer kilometers annually in the proposed case. Also, the purchase cost of the Prius is just under $5,000 more per vehicle, or $24,485 in additional initial costs for all 5 vehicles. The pickup trucks have been broken into 2 groups. In the first, the trucks run on gasoline in the base case, but diesel in the proposed case. In the second, the fuel is gasoline in both the base case and the proposed case, but the proposed case trucks are more fuel efficient. The comparison for sport utility vehicles is very similar to that for gasoline pickup trucks or the cars. A more fuel-efficient vehicle is chosen and, as with all the others, the carpooling policy has the effect of reducing the distance driven. Last, for the vans, the incremental initial costs are blank. This is appropriate since the same vehicle is used in both the base case and the proposed case. The Dodge Grand Caravan FFV is a flexible fuel vehicle, however, and it is assumed that it operates exclusively on gasoline in the base case and E85 in the proposed case. The choice of fuel affects the efficiency, so when the vehicle is selected in the product database, the database entry for the vehicle running on gasoline must be chosen for the base case, and the entry for the vehicle running on E85 must be chosen for the proposed case. If we wish to include other vehicles in this fleet, we could click on the plus sign. Similarly, we could delete vehicles from the fleet by clicking on the minus sign icon. The table at the bottom summarizes the consumption of each fuel type as well as the total consumption of fuel energy in kilowatt hours. The savings in fuel and dollars and the incremental initial costs are calculated. These figures are taken back to the include measure table, allowing for the simple payback for the entire collection of vehicles in the proposed case fleet versus the entire collection of vehicles in the base case fleet to be estimated at just over 7 years. Note that this example project consists of a total of 119 vehicles. From the first line in the table, there will be either a Nissan Leaf or, if the include measure box is unchecked, a Honda Civic. From the second line of the table, there will be either a Toyota Prius Prime or a Honda Civic. And then there will also be the 117 vehicles of the example fleet. If we uncheck the include measure box for this row, the 117 vehicles will be the ones associated with the base case rather than the proposed case. This concludes our exploration of RETScreen's built-in example of feasibility analysis for a fleet of vehicles.